polyvinyl alcohol. You probably never heard of it before today, but that's going to change. It starts innocently enough, you go to the grocery store, you see this new detergent, it comes in pods, it doesn't come in a traditional plastic bottle. It's also riddled with words like biodegradable and eco-friendly. What could go wrong? So you buy a pack, take it home, put it in with your dirty dishes, your dirty laundry, and all is well with the world. Or is it? These pods are made out of a plastic material called polyvinyl alcohol. I told you you'd remember it after today. This polymer is known to be water soluble, meaning as soon as it interacts with water, it starts to break apart and turn into a solution, thus releasing the contents inside. But soluble in water does not mean it disappears. If you think about taking a couple spoonfuls of sugar or salt and putting it in a glass of water, it might disappear, but if you drink the water, it's going to taste like sugar or salt. Like a lot of other bio-based polymers, this material is technically biodegradable, but the conditions needed for it to biodegrade fully are not met either in wastewater treatment plants, which is where the water goes once it leaves your house, or in the environment. Those strict conditions include having the right temperature, having the right pH, having the right species of microorganisms, having the right concentrations of microorganisms, and more. So what happens to this stuff once it leaves our house? Right? We use it, goes down the drain, goes to a wastewater treatment plant, potentially into the environment. This was the question that we begged to answer. Thus, we teamed up with Arizona State University and Blue Land to put together a study to find out what happens to this PVA. Co-first author and PhD candidate Varun Kelkar and I began by scouring the literature that had already been published to see what types of degradation rates and circumstances existed for polyvinyl alcohol. What we found wasn't good. We then created a model which took that previously published information along with how many pods are used in the US and current wastewater infrastructure to extrapolate how much PVA is treated and how much PVA remains intact passing through conventional water treatment into the environment. Our research demonstrated that only about 25% of the incoming PVA actually degrades. The remaining 75% passes through conventional water treatment into ecosystems beyond. That 75% of untreated PVA equates to about 600 million plastic soda bottles worth of plastic untreated into the environment, into the ecosystems beyond. So what happens next? We don't know. We know that once materials are treated in a wastewater treatment plant, they'll either leave in the aqueous phase as effluent or they'll leave in the solids phase as biosolids. Biosolids, which are actually super rich fertilizer, are either sent to a landfill, incinerated, or land applied for agricultural reasons. We also know that PVA is hydrophilic, meaning it actually likes water. So there's a lot of contaminants that exist in different environments that are hydrophilic, and hydrophilic plus hydrophilic means there's an attraction, and PVA could potentially sequester some harmful contaminants. We know that PVA can absorb heavy metals, for example, at certain concentrations, which might be dangerous. It can also affect the gas exchanges in aquatic ecosystems, meaning it can change the oxygen or the CO2 available. It also releases ethylene, and ethylene is a plant-based hormone that could affect crop yields if it is applied on land and biosolids. This is just stuff that we need to investigate further. Ultimately, we need to understand what happens to this PVA that's still intact, that's resisted degradation. How does it behave as a pollutant? This also speaks very loudly to truth in labeling. What happens a lot of the time is companies will test a certain material under optimal conditions, it'll break down well, and they'll slap a biodegradable label on it really quickly. Now, if they replicated the conditions outside, actually in the environment, it might not degrade so quickly. So these are what we have to be much more efficient and accurate with. These things are making truth in labeling a really big issue right now. Now, I'm not trying to vilify the material because the material does its job very well. But if we're saying it's eco-friendly and biodegradable, that's the problem. Now, as a biologist, I have a unique perspective into this, but really what I want to get more information on was an engineering perspective. So I spoke to co-first author Varun Kelkar to see what he thought about this research. All right, so first of all, thanks for joining me. And I did hear that this research was actually conducted with another extremely handsome scientist. So that must have been nice. But one of the questions that I keep getting is if these pods aren't turning into microplastics, what are they turning into?
Think of it like sugar or salt in water. It just mixes it. It converts into a solution form, and you can't really tell it apart. But that's how PVA forms. It forms into a gel-like substance when it mixes with the water. So it's completely transparent. It does not have any odor or color. So I think salt and sugar will be a great analogy for PVA.
Do you think, if there was enough concern about this, about the fact that PVA is going to our water, it's not really breaking down, do you think there could be modifications made at wastewater treatment plants that would allow for a better breakdown, or is it kind of just going to stay as is?
I think we need to do a cost analysis, I guess, because there are so many chemicals coming in a wastewater treatment plant from so many different sources. If you only focus on one, we have to first take into account how much environmental economic risk it is posing to the environment. And if the amount of efforts we need to put in are lesser than the economic risk it poses, I think it makes total sense. But otherwise, I don't see going out of a way to correct the PVA is a economically smart decision. And I say economic because it's not because I don't care about the environment. It's because these treatment plants are municipality owned and they have budgets. So if it's not in their budget, they're not going to do it. So we have to do like an economic risk analysis.
Makes sense. So as an engineer, if you receive a package of some of these pods and it says eco-friendly on the outside, in your opinion, is this true?
I'm agnostic. I don't know. I don't think it's true, and there's no evidence to say it's false. So there's no evidence so far telling that this is eco-friendly, and there's no evidence saying this is very harmful to the environment. All we know is that this does not biodegrade. So yeah,
so putting biodegradable on the outside, how about that? If the package says 100% biodegradable, okay,
that's false.
That's
there should be like a big asterisk, and they should explain in the asterisk what conditions are needed for it to be biodegradable. And if you're living in Alaska, good luck.
That's a good point. And so I guess from your perspective, then the question is, what does biodegradable mean?
Anything which can be immediately be bioavailable in the environment, 100%. For example, like a banana peel, or even any organic matter like human body or an animal carcass. So all those things vanish after a given amount of time, and you know for sure it will vanish. With these chemicals, we don't know if it's going to vanish, and what exact conditions need to be met for it to vanish under what amount of time. So the timing has to be reasonable, is my point.
Okay. That makes a lot of sense. Yeah. The last thing I was going to ask is, obviously there was some research done with this material for people to be able to say this is 100% biodegradable, but we know that fell short a little bit. So what needs to be done in the future with new materials to ensure that when you say something is 100% biodegradable, it actually is?
I'm not an expert in the biodegradable studies that they do. But if you want to claim something as 100% biodegradable, the experiments have to be done mimicking the natural environments they're going to be in. If you're going to control the environment and make it a very optimal for it to degrade, then it's a no-brainer. It's going to degrade in some amount of time. And the studies actually we saw, they don't say it degrade 100%. I think they had certain percentage still remained after a good amount of time. I think it was 60 days or something. So, I mean, I don't know the exact experimental design right now, what needs to be done. I think it depends on the material and depends on where is the final destination of that material. So yeah, I think it's dependent, but it can be made. A good design could be made.
And there you have it. I told you you'd learn something about polyvinyl alcohol today. Now we know. Now we know when we go to the detergent section of the grocery store, it's actually kind of important to look at the labeling. It's important to see if this is claiming to be eco-friendly or biodegradable. It's important to look at the ingredients. Are we putting stuff into our gray water that shouldn't be in there? This is a pretty big wake-up call. You know, truth in labeling is an important issue, and it's something that we should be aware of every time we go to the grocery store, every time we shop online. It's a really great thing to think about moving forward. So thank you for watching. Until next time. I want to thank you guys for watching the video. If you appreciate it, if you have suggestions, definitely leave us a comment, leave us a question. If you would like us to cover certain stories in the future, please email us at science@plasticoceans.org. Thanks for watching.